Welcome back, students. So we will do problems related to graph, means a question, graphical question will be there. From the graphical question, we need to find the acceleration, what type of motion it is, what is the distance travelled in that case. So here we will not use the equations of motion. We can't use the equations to find distance, that is S is equal to ut plus half a t square or v square minus u square equal to 2as. If you are asked to find the acceleration, we can't use the equation a equal to v minus u by t. So now how will you find the acceleration? If a graphical question is given, then how will you find the acceleration? Means you need to find the slope of the graph. You need to find the slope of the graph, that is y2 minus y1 by x2 minus x1. Using that equation, we can find the acceleration. Now, if you are supposed to calculate the distance, then you have to find the area under the velocity time graph. So, what is the shape of the graph? What is the area under that graph? That will be equal to the distance travelled. If it is in the shape of a triangle, then you can use the equation half bh. If it is in the shape of a rectangle, L into B. If it is in the shape of a trapezium, half into A plus B into H. Both together you will get, sometimes you will get a trapezium and a rectangle together. So, half into A plus B into H plus L into B. Otherwise, you will get, suppose you will get a shape like this, triangle plus rectangle. So, half BH plus L into B. So, here we can't use the equations. From the graph, we will calculate the area, that is the shape of the graph. Depending upon the shape, means what is the area, shape of that area, shape of that area, that give the distance travelled. Then to find the acceleration, we need to find the slope of the graph. Okay. So, that is about graphical problems. So, first question is this one. The graph given below shows how the speed of a car changes with time. The graph given below shows how the speed of a car changes with time. So, speed and time graph. Speed is represented along the y axis. Time is represented along the x axis. Here the graph starts from this point O, here B, here C, here D, then E is there, F is there, O means the origin, this point is A. Along x axis we plotted 10, 20, 30, 40, and along y axis along x axis we plotted 2, 4, 6, 8, 10, 12, and along y axis it is plotted 10, 20, 30, 40. Means velocity or speed is represented along y axis, time is represented along x axis. Now, the question is, what is the initial velocity? What is the initial velocity? There is a small change in the shape of the graph, that is, the graph actually starts from this point. There is a small change in the shape of the graph. Actually, the graph starts from this point 10, velocity 10. So, what is the initial velocity? Here the graph is not starting from the rest, means or from the origin, means it is having some initial velocity. It is not starting from rest or it is not starting from the origin. So, it is having an initial velocity. So, what is the value of the initial velocity? From where the graph starts, that is the value of initial velocity. So, here the graph starts from 10. So, initial velocity is from where the graph starts, that is the initial velocity. So, initial velocity is initial velocity that is equal to 10 meter per second. 10 meter per second. That is the initial velocity. Now, what is the second question? What is the maximum speed attained by the car? What is the maximum speed attained by the car? Here you can see from A to B. From A to B, then it's a slanting line. Then after that, from B to C, it's a straight line parallel to the time axis. From C to D, it's a curved line. That curving is towards the time axis. Okay. So, what is the maximum speed of the car? So, what is the maximum value of velocity represented by the graph? What is the maximum value of the velocity represented by the graph? That is the maximum speed. So, here it is from B, that is the maximum value of velocity. This point represents the maximum value of velocity. So, what is that? It is almost 25 meter per second. Almost it is 25 meter per second. It is 25 meter per second. So, maximum speed (25 meter per second). That is the maximum speed attained by the car. It's between 20 and 30. Okay, the B point, I have drawn a dotted line here, this dotted line. So, that represents the maximum value of velocity which is represented in this graph. So, that is in between 20 and 30, that is 25 meter per second. Now, third question, which part of the graph shows zero acceleration? Zero acceleration means the graph should be parallel to the time axis. Zero acceleration means there is no change in velocity. There is no change in velocity means final velocity and initial velocity is the same thing. Final velocity and initial velocity is the same thing. There is no change in velocity. So, acceleration will be 0. Okay. So, acceleration 0 means the graph will be parallel to time axis. So, in this portion or in this graph, which portion is parallel to time axis? Which portion of this graph is parallel to the time axis? It is a straight line parallel to the time axis. So, in this graph, which portion is parallel to time axis? That is this portion. This portion is parallel to time axis. So, which portion represents zero acceleration? Zero acceleration is represented by BC. So, BC represents zero acceleration. The reason also you have to write. What is the reason? Graph is a, or we will write it clearly, that is velocity time graph is a, VT graph is a straight line. VT graph is a straight line parallel to time axis. Parallel to time axis, VT graph. VT graph is a straight line parallel to time axis. Then next question is, which part of the graph shows varying acceleration? Which part of the graph shows varying acceleration? Means changes will be there in the acceleration. The acceleration is not a constant value, not 0, but changes will be there in the acceleration. So, it is not represented by the straight line. It is not represented by the straight line. Here it is represented from A to B, it is represented by a straight line sloping in the upward direction. So, that means the acceleration in that part AB is uniform acceleration in that part AB. The slope is in the upward direction, or it is sloping in the upward direction. So, the part AB represents uniform acceleration, BC represents 0 acceleration because it is a straight line parallel to the time axis. Then what about CD? The graph is a varying one. The graph is a varying one. It is not straight line. It is a curved line. So, that part represents varying acceleration. So, which part represents varying acceleration? That is CD. So, fourth one, varying acceleration CD. Now, fifth one, what is the distance travelled in first 8 hours? What is the distance travelled in first 8 hours? Means till here. Till this point, what is the distance travelled? So, what is the shape of the graph? I will draw the shape of the graph here. This is the shape of the graph. That is, this one is A, O, B, C and E, I think. F. What is the name given here? F. So, this one is F. Now, this is a shape, that is the area under velocity time graph. That is the area under velocity time graph. So, we need to find the area of this pattern or this shape, then you will get the distance covered in first 8 hours. So, here I will divide this area like this. This point is E. So, this one looks like a trapezium and this one looks like a rectangle. Now, I will give the values. Here it is 10, here it is 25, here 3, here 8. So, how will you find the area? So, distance travelled equal to area of trapezium, that is O, A, B, E plus area of rectangle B, C, F, E. Now, we will write the equation, that is distance travelled is represented by the letter S, area of the trapezium half into A plus B into H plus area of the rectangle, that is L into B, that is half into sum of the parallel sides is 10 plus 25 into Now, what is the distance between this one? 3 into 3 plus length is 25 into breadth 8 minus 5, sorry 8 minus 3, that is 5, 8 minus 3. So, I will write it like this, equal to half into 35 into 3 plus 25 into 5. You can do the calculation and find the answer. You can do the calculation and find the answer. So, how you calculated this one? Initial velocity means the starting velocity of the object. Maximum speed, the maximum value attained by the graph. In this case, okay, when you plot it, what is the maximum value attained by the graph? That is the maximum speed. Then uniform accelerated motion means if the graph is sloping in the upward direction. If the graph is sloping in the upward direction, then uniform accelerated motion. If it is parallel to time axis, means straight line parallel to time axis, then that represents 0 acceleration. Then if it is curved line, then it represents varying acceleration. If it is a straight line sloping in the downward direction, means towards the time axis, then the acceleration is negative, negative acceleration. If you are asked to find the acceleration, then you can use the equation y2 minus y1 by x2 minus x1. If you are asked to find the distance, then what is the shape of the area under the velocity time graph? Find the area that will be equal to the magnitude of displacement. Okay, that is about the first question. Now, second one, study the velocity time graph and calculate the acceleration from A to B. Calculate the acceleration from A to B. That is, what is the acceleration from this point is A, this point is B. So, what is the acceleration from A to B? Second question, the distance covered in the region ABE. So, what is the distance covered? A, B, E. What is the shape? What is the shape of the area under the velocity time graph? Okay. Then that is, you will get the distance travelled. Then average velocity from C to D. Average velocity from C to D. This point is C and this point is D. Now, what is the distance covered in the region B, E, F, C? Means this portion B, E, F, C. So, what is the shape of that region? That will give the area of that particular, what is the area of that particular space, that is equal to the distance travelled. Okay. So, if you are asked to find the distance travelled, you just find the area of the shape enclosed by the velocity time graph. So, we will do the first one. What is the first one? Find the acceleration from A to B. Acceleration. So, acceleration equal to slope of VT graph. Slope of VT graph, that is equal to y2 minus y1 by x2 minus x1. Now, just I will rough draw this graph here, or leave that portion AB. This one is y axis, this one is x axis, this one is A, this point is B, this one is 25, this one is 0. So, this one is y2, this one is y1. Now, B, this one is 3. So, this point O is x1, this one is x2. Okay. So, just I draw that only that portion AB here. So, B, it's 25 meter per second, 25 meter per second, there it is in. So, that is y2, 0, the graph starts from here 0. So, this one is y1, then from this point B I have drawn a line to the x axis. So, that is x2, then this is x1. So, what is the equation to find the slope of the graph? y2 minus y1 by x2 minus x1, that is equal to y2 is 25 meter per second minus y1 is 0 because the graph starts from the origin. So, y1 is 0, that is 0 meter per second divided by x2 is 3 seconds. From B I have drawn a line such that it will meet the x axis, that is the x2. So, x2 is 3 second minus x1, yeah, this one, that is 0 seconds. So, what is the answer? 25 by 3 meter per second square, 25 by 3 meter per second square. Now, what is the second question? Second question means you have to find the displacement, means area under the velocity time graph. The shape is ABE. ABE. So, A, B and this point is E. This point is E. So, what is this shape? What is this shape? That shape is of a right angle triangle. So, how will you find the area? Area distance travelled equal to distance travelled or magnitude of displacement, magnitude of displacement, magnitude of displacement equal to area under VT graph, area under VT graph, that is area of right angle triangle ABE, that is equal to half BH, that is equal to half into B, half into B means what is the base, that is 3, H means height, that is 25. So, half BH equal to half into 3 into 25. So, find the, when you do it, you will get the answer in meters. You will get the answer in meter. So, half BH. Okay. Now, what is the average velocity from C to D? What is the average velocity from C to D? That is from this portion to this portion. What is the velocity from C to D? From this portion to this portion. Okay, that is the average velocity. Now, we need to find the average velocity of that portion. So, third one, average velocity average velocity from C to D. The equation is u plus v by 2. What is the initial velocity plus final velocity divided by 2? That is the average velocity. So, I will draw the graph again here, just only that portion. This is C, this one is D, this point is 6, 0, x axis, then this value here it is 16 meter per second. I will take it as 16 meter per second. So, what is the initial velocity plus final velocity divided by 2? So, this one is initial velocity and this one is final velocity. Okay. So, C represents the initial velocity and D represents the final velocity. So, that is 16 plus 0 by 2, that is 8 meter per second. 8 meter per second, that is the average velocity. Then one more question is there, that is the fourth one. What is the distance covered by the region BEFC? That is this region, this shaded region, that is BEFC. So, what is the shape? That is of a trapezium, that is of a trapezium. So, you will find the area of the trapezium, then you will get the answer. So, distance equal to area under VT graph, that is equal to area of trapezium. The name is BEFC, that is half into A plus B into H, that you will get it as like this, half into A is 25 plus B 16 into H 1. When you do the calculation, you will get the answer. Here 1 means 3 minus 4, sorry 4 minus 3, 4 minus 3, that is the distance between the two parallel sides. Okay. So, you will get the, when you calculate it, you will get the area of that trapezium, that is equal to the distance travelled. Okay. Now, one more question is there, that is this one. The shape of the graph is like this. The question is, study the velocity time graph and calculate the type of motion represented by OA. The type of motion is represented by OAB and the type of motion represented by BC. Okay. So, here the graph OA, the graph is sloping upwards. It is a straight line graph sloping upwards. So, I told you it is having uniform acceleration. Uniform acceleration. Now, what about this portion AB? Graph is a straight line parallel to the time axis. So, acceleration will be 0. Acceleration will be 0. Now, what about this graph BC? That part is sloping downwards. That part, the slope is downwards. So, it is having uniform retardation. It's a straight line, slope downwards. So, it's having uniform retardation or negative acceleration. So, first 3 questions we will answer it now together. That is, phase 1, OA straight line, slopes upwards. So, uniform accelerated motion. Then AB straight line, parallel to the time axis, So, 0 acceleration or no change in velocity. Then third one, BC straight line, slopes downwards. So, uniform retarded motion. That is about the first 3. Then fourth one, find out the acceleration from O to A. Fifth one, find out the retardation of the object. Retardation means the acceleration should be negative. Acceleration is negative means the slope is downwards. The graph is sloping downwards. So, this portion represents the retarded motion. This BC represents retarded motion. Okay, BC represents retarded motion. So, you need to find the acceleration, retardation and the distance travelled. Distance travelled from A to B means this portion. What is the shape of this portion? That's of a square. So, side into side. So, fourth one, we need to find the acceleration. A equal to slope of VT graph, that is y2 minus y1 by x2 minus x1. I will just draw the graph, only that portion I will draw here. This one is O, A, this one is the axis. So, here 6 meter per second, here time is 4. So, this portion is y2, this one is y1, this one is x2, this one is x1. So, y2 is 6 minus 0 divided by x2 is 4 minus 0, that is equal to 6 by 4, 3 by 2, that is equal to 1.5 meter per second square. 1.5 meter per second square. Now, which portion of this graph shows retarded motion? That is BC. BC. You can find the retardation. Then also you will get the answer like this. I will just write it like this. Retardation you will get it like this. Y2 minus Y1 by X2 minus X1, that is equal to 0 minus 6 divided by 16 minus 10. 16 minus 10, that is equal to minus 6 by 6, that is minus 1 meter per second square. This one is not asked in the question. Just from that slope you can find the retarded motion. Then one more question was there, that is the area. So, sixth one, distance equal to area under VT graph, that is equal to, it's of a square, so L into B, rectangle, side into side or square. So, if you consider it as a square, then side into side, rectangle, then length into breadth. So, you will get the answer 6 into 6, that is 36 meter, you will get the answer. Okay. So, if the question is about to find the acceleration, use the equation y2 minus y1 by x2 minus x1. If you are asked to find the distance travelled from the graph, just find the area under the velocity time graph. Means what's the shape of the area. If it is a rectangle, L into B, trapezium, half into A plus B into H, triangle, half into DH. Any of what, depending upon the shape, you find the area. Okay. Thank you.